Well, good day to you, my dear friends. It's time to solve some LeetCode problems. Yay! Ooh. There was a contest today, and then I participated in a Leet room, and now I can't think at all. But still, we can talk about some problems from the past. For example, a few days ago we solved this beast. Come on. Let me go back to my original solution. So, what do we have to do here? We have an array of nums, and we want to return another array where we put elements from our original array until I can't think. What did we do here? Yeah, the sum of elements in this array should be bigger than the sum of elements that are left in our original array. And I did it the easy way. You know, I sorted everything and I took this maximum element . This is it, and I put it in our final array. And also I have left some variable. It's the sum of all elements minus this one, the biggest one. And then we go, you know, we take one element, like maximum, from the array, we put it to the right sum, we subtract it from left sum, and we compare everything. And I checked the solutions section, and it's pretty much the same thing. The only difference is we do not need this left sum variable. Let's do something like and now we can do while right sum is less or equal than sum minus right sum. So we do not need this left sum variable anymore, and it's a little shorter, you know. I hope. Let's check. Yay! Also, because we have this index, we don't need this new array of results. We can just take our sorted nums we're gonna take elements from index plus 1, because, you know, we overdid it by 1. while doing this while loop, so we want to increase it, and -1, probably like this. Let's check. It's gonna be wrong for sure, because yeah, the order is wrong. Also, we want to reverse everything. So we do not need result anymore. And it's even shorter now. Great. And of course this reverse can be done earlier. Like you see, this is an example, but I will have to rewrite my while loop if I want to do that. And it's better probably to do reverse on this smaller array. But actually it doesn't even matter if array is a little smaller or a little bigger. For us programmers, it doesn't make much of a difference. Maybe there are some better solutions, but we will never know, because there are only 2 solutions in this section and they are, well, similar. Now, let's solve a problem from the first page. Ooh, can you hear my cooler? So, easy problems, maximum acceptance. All done. It's time for smallest even multiple. Well, it's an easy problem. No surprise here. So we have a positive integer n. We need to return the smallest positive integer that is a multiple of both 2 and n. So for 5 we want to return 10, because 10 can be divided by 2 and by 5. But for 6 it's just 6, because 6 can be divided by 6 and by 2. You see? So it's obvious that if we can do this like if n, no, like this, equals 0, then we have an even number, and if we have an even number, then we have this case, then we just want to return n. Otherwise we want to return double n. Yeah, and of course we can do something like even. It's a little shorter. Or even we can do odd, but we have to change the order. And it's even shorter by 1 symbol, by 1 character. And that's it. It's hard to imagine a better solution for this problem. Oof. Also recently I started to go through, let me show you, a roadmap made by LeetCode. And the first problem here is contains duplicate. Let's also discuss this one while we are at it. Well, I already showed you the easiest solution. So, given an integer array nums, return true if any value appears at least twice in the array, and return false otherwise. Well, of course we can solve it with hash. Let's iterate. And here we want to return false. So if hash num already exists, then we want to return true. Else we want to do hash num, I don't know, equals 1 for example, or equals true. It doesn't matter what we put there. Let's check. So if our hash doesn't contain this number, we put it into our hash, and when we encounter this number again, this hash already has this number, so we return true because this is a duplicate. Otherwise we return false. And we can do this a little shorter using guard clause, like just return true if hash name, and do that a little better. And of course we can do this, as a one-liner. Maybe it's not as effective in terms of time, in terms of time complexity, but let's do it still. So we can do num's size. We can compare it to num's unique size. If it's the same, then we do not have any duplicates. Probably like this. Yeah, great. But in fact, it can be done even easier. We do not need size for that. We can just compare arrays, because if there are no duplicates, they should be exactly the same. Oh, and also I've seen a funny solution using sets. Yeah, Ruby has this class of sets that no one uses, but this is a case where we can use set, because sets, they are like arrays, but they can't contain any duplicate values. So we can convert our nums to set, and we're gonna check the size of this set and compare it to the size of our original array. Because every day we want to learn something new. We have toSet method in Ruby. And somewhere there was even a funnier solution with set. Elegant solution with set. Yeah. You see, we try to add, we create a new set, we go through nums, and we add these elements to this new set. And then we try to add it, and if there is a duplicate, we can't. It's kind of funny. I love that solution. It's beautiful. So this is a problem 217 contains duplicate, and it's the first problem from LeetCode's roadmap. Now let's solve something new. Oh, but I'm so tired after everything today. I don't know if I can solve a medium problem I failed a couple of medium problems already today. Luckily not during a stream, otherwise I would be, stuck and spend another 5 days trying to solve these problems. But I'm not that. But I do not follow this rule when I try to solve something offline. So, medium difficulty. Acceptance. Partition array according to given pivot. What? It even sounds bad. Okay. Okay. So, pivot is 10. So everything lesser than 10 should appear before. Then tens, then everything that is bigger. Yeah. Every element equal. Yeah. Appears in between. Makes sense. The relative order of the elements it looks like we can just sort everything and don't give a fuck about this. Oh, they care about order? Yeah. That's why we can just sort them. Okay, let's continue reading. Oh yeah, it's the next line. We have to maintain the order more formally. Thank you very much, but no. Okay. Oh. Let's do this the ugliest way possible. Wait. Because they do not ask us to do everything, in place, on the go. I'm too tired to do it any other way. So, if num is less than pivot, we're gonna add num to array first. Else if num equals, we're gonna add it to second. Finally, return nums after the rearrangement. So we want to do this on nums, not this ugly way. Well, let me finish it, just, for fun. Because programming is fun, never forget that. And now we want to do something like nums equals first plus second plus third. But how can we do this on a go without using something like bit manipulation, which is way above my pay grade? Okay, I have an idea. So we're gonna iterate, of course. Let's iterate with index. We're gonna use offset. It is 0 by default. It's somewhat similar to what I did yesterday or 2 days ago. Do num I. So if num no, it can't be done like this. So if num is less than pivot, we do nothing. So let's check if num is more than pivot. No, let's call it current index. It's gonna be equal to I plus 1, and while we have nums and let's store this value somewhere. While nums I plus 1. Of course it's bad. It's just like using insert. Oh, it can be very big. So no. Let's not do that. Can we sort by that? Okay, we can do this the ugly way. Or not. No. These tens in the middle, they are bad. Well, it's easy to do using additional arrays or some kind of hash or something like this. But how to do this while iterating, I don't know. Only using bit manipulation, but I don't really understand it. Okay. Come on. Good enough for me. Although 400, almost 500 milliseconds. That's bad. We'll think about this problem tomorrow. And for now, let's have some rest. Enough is enough. So thank you very much. Don't forget to follow, to subscribe and whatnot. And I'll see you tomorrow. Goodbye, my dear friends. Have a nice weekend too.